Welcome to The Explainer. Today, we're diving into the colossal, unseen, beating heart of global commerce liner shipping. When we think about how the world works today, we often picture digital clouds of data or bustling city streets. But the reality of our global economy is intensely physical. It's made of saltwater, steel, and machines of truly staggering proportions. Today, we're pulling back the curtain on the invisible machinery that brings you practically everything you own. We'll be exploring the towering steel walls, the brilliant logistics, and the harsh physical realities of the ships that literally carry the weight of the world. 200,000. Just take a moment to let that sink in. This isn't a fleet. This isn't a decade of trade. This single number represents the container loads that just one massive container ship carries in a single year. To put that into perspective, if you were to unload those containers and put them on trucks, you'd have a line of traffic stretching all the way across continents. To move this amount of cargo without that single vessel, you'd need hundreds of freight aircraft, miles upon miles of rail cars, and massive fleets of trucks burning through fuel. The sheer scale we're dealing with here is just awe-inspiring. It really sets the stage for an industry where massive is literally just the baseline.
And here's exactly why our modern survival relies on these ocean leviathans. 60%. That's the percentage of all internationally moved goods, by value, that travel by sea on liner vessels. As consumers, we've grown so accustomed to seeing products from every corner of the globe magically appear on our store shelves, right? But that magic is purely mechanical. Liner shipping connects countries and markets on a scale that was previously impossible. It injects hundreds of billions of dollars into the global GDP and arguably maintains international security simply by keeping the lifeblood of trade flowing.
Let's move into Section 1, Mapping the Ocean Arteries, the Master Plan. Think of this like a global military tracking dashboard. To actually master the globe, shipping lines rely on 4 highly precise maneuvers. First up, you have the end-to-end service, your traditional back and forth, swinging between port ranges like India and Europe. Then there's the round-the-world, continuous circumnavigation. But that one's restricted because ships have to be small enough to fit through the Panama Canal. To fix that bottleneck, we invented the pendulum route, swinging across major oceans but completely skipping the Panama Canal to allow for massive vessels. And finally, look at the hub-and-spoke model at the bottom. This is the real star of the show. Giant mainline ships stop only at massive hub ports, and then smaller feeder ships disperse the goods locally. It's the absolute backbone of modern deep-sea container services. But here's the crucial point. Success in this industry isn't just about floating heavy things on water. It's about executing a tightly synchronized intermodal network. Liner ships don't just operate on a whim. They run on fixed routes with strict, predetermined arrival and departure schedules, relying on incredibly tight windows for berthing at ports. Supply chains today aren't port to port. They are door to door. Picture a heavy steel container swinging from a towering crane, locking onto a waiting train in the dead of night, and gliding seamlessly onto a highway truck by dawn. It's a ballet of steel. If there is a delay anywhere, a congested port, a broken rail line, it creates a ripple effect that disrupts the entire global sequence. The choreography has to be absolutely flawless.
Section 2. Rise of the Titans. The escalation.
This whole thing started from incredibly humble beginnings. The very first container ship was the Ideal X back in the 1950s. It wasn't some futuristic, purpose-built vessel. As you can see, it was literally a converted World War II T-2 tanker. Back then, containerization was a completely untested, risky technology. Ports didn't even have cranes to lift the boxes, so these early ships had to carry their own onboard cranes. They were slow, makeshift, and totally improvised. Now, check out this timeline. It plays out almost like a cinematic tracking shot showing aggressive, relentless expansion. We jump from the makeshift 1950s to 1968 when the first fully cellular container ships arrived, designed purely to stack containers like massive steel Lego blocks. By 1985, ships maxed out the exact dimensions of the Panama Canal, the Panamax standard. But global trade wouldn't stop growing. So by 1996, shipping lines simply bypassed the canal entirely, and the wider post-Panamax ships were born. Then came 2006 with very large container ships, and by 2013, the ultra-large container ships, plunging us into an era of true mechanical giants. Just look at the sheer vertical explosion in carrying capacity here. It wasn't a gradual slope, it was an absolute rocket launch. We went from a strict limit of 4,000 containers in 1985 to the Neo-Panamax class holding 12,500, all the way up to ultra-large container ships carrying 18,000 or even 20,000 containers today. Why? Well, it's the relentless pursuit of economies of scale. It creates a virtuous circle.
The more containers you pack onto a single ship, the lower the cost to transport each individual box. It makes shipping so incredibly cheap that it fundamentally changes what's economically viable to buy and sell across oceans. And guess what? The engineers aren't even close to done. Sitting right now on the drawing boards are theoretical sci-fi leviathans known as the Malacca Max. These ships are designed to carry up to 30,000 containers at once. They're just waiting in the wings, fully designed and ready to be willed into existence the very moment global trade volumes are high enough to make building them profitable. So we've seen this incredible triumph of human engineering, pushing boundaries to squeeze out every single drop of efficiency. But it raises a massive, almost existential question. How big is too big? At what point does human ambition collide with the unyielding physical limits of planet Earth? Well, here's the harsh reality check: the infrastructure bottleneck. Every time a new generation of monster ship is launched, it faces a rapidly shrinking number of harbors capable of actually handling it. First, you literally breach the physical locks of the Panama and Suez Canals. Then, these heavier ships require deeper water, which puts massive financial pressure on local governments to spend millions violently churning up and dredging the ocean floor. And finally, you need entirely new equipment. Ports are forced into immense capital investments to buy highly efficient but ridiculously expensive, wider-reaching portainer cranes just to reach the boxes stacked on the far side of the ship. Because of all these intense physical and financial pressures, bigger isn't automatically better. The limits of economies of scale aren't just technical, they're deeply commercial. The industry has actually found an operational sweet spot. Container ships carrying between 6,500 and 9,000 containers often provide the absolute best commercial flexibility. They sit in this perfect Goldilocks zone, big enough to be highly efficient, but small enough to still access a wide variety of ports and service diverse markets, rather than being locked into only the 2 or 3 megaports on Earth capable of holding the ultra-large vessels. Which brings us to Section 3, the reality check: nominal versus effective capacity. This comparison perfectly contrasts the dream against the harsh reality. On the left, we have nominal capacity. This is the geometric ideal. It's the shiny number you see in the press releases. It assumes a perfect world where all containers are totally empty, perfectly identical in size, and the ship is sailing a flawless route. But over on the right is the effective capacity, the real world, the messy reality. It factors in heavy container weights, the actual draft limitations of the ports you're visiting, and the absolute safety requirement of leaving top decks empty of heavy boxes so the ship doesn't, capsize in the rolling ocean. Our source material gives us a really fantastic grounding example to prove why this distinction matters so much. Take a ship like the CMA CGM Vittoria. On paper, its geometric nominal capacity is 2,592 containers. But when reality sets in, when the boxes are actually filled with heavy goods, when those ocean draft limits are applied, its real effective capacity drops to just 2,080 containers. Over 500 containers of theoretical capacity just vanish the moment the ship interacts with the real world. You can design a perfect ship, but you still have to sail it on an imperfect planet. And that wraps up our dive into the invisible machinery of global trade. We started with makeshift tankers, and we've arrived at 20,000 container leviathans that require us to literally carve out the ocean floor and reconstruct the coastlines of continents just to let them park. It leaves us with a truly profound question. Are we building ships to serve the world we live in, or are we being forced to fundamentally reshape the physical world just to serve our ships? The next time you order something online from across the globe, think about the immense, unseen titans making it possible. Thanks for joining me for this explainer. Keep wondering, keep learning, and I'll catch you on the next deep dive.